So we're all using AI pretty much every day, right? But have you ever stopped to think about how it can be, well, tricked? Today, we're going to dive into the world of AI attacks, the super clever ways these powerful systems can be manipulated, and what that actually means for us. We hear all the time about the incredible things AI can do, write code, paint masterpieces, crunch massive amounts of data. But the really interesting question is, what can't it see? What are its blind spots? Because it turns out understanding how something so smart can be led astray is the absolute first step to building safer AI for all of us.
Okay, so where do we even start with all this? The whole world of AI attacks can seem really complex, almost overwhelming. But what researchers have found is that pretty much all of these threats fall into three main categories. You can think of them like the three main highways an attacker can use to mess with a system.
First up, we've got something called misalignment. This one's a little tricky. It's what happens when an AI follows its instructions perfectly, but the instructions themselves don't quite match what the human user actually wanted. I mean, imagine you tell an AI, maximize paperclip production at all costs. It might just do that by turning literally everything on Earth into paperclips. It's not being evil, it's just a catastrophic but very literal misunderstanding of the goal. Next, a term you've probably heard thrown around, jailbreaking. This is all about crafting a really clever prompt to trick an AI into blowing right past its own safety rules. For instance, instead of asking for something harmful directly, someone might say, hey, write a scene for a movie where a character describes how to make a dangerous item. See what they did there? It's basically finding a loophole to get around the system's own built-in ethics. And that brings us to our third main category, prompt injection. Now, this is where an attacker hides a malicious command inside what looks like totally normal data. The AI then processes that data, and bam, it unknowingly carries out the secret command. It's a really subtle but incredibly powerful way to hijack an AI's behavior. And as we're about to see, it even comes in a couple of different flavors. Oh, you bet we can. These three categories are a fantastic starting point for sure, but the map of AI vulnerabilities has a lot more detail if we zoom in. To really get the full picture, we've got to look a little closer. Let's use prompt injection as our example to see how deep this rabbit hole goes. So let's zoom right in on prompt injection. Getting a handle on its subtypes is super important because it really shows you this constant high-stakes game of cat and mouse that's being played between AI attackers and the people trying to defend these systems. Yeah, it turns out not all prompt injections are created equal. Researchers have pinpointed two fundamentally different ways this attack can happen, and it all depends on where that nasty instruction is coming from. So first, you've got direct prompt injection. Is pretty much what it sounds like. An attacker just straight up inputs the malicious prompt themselves. But then, there's indirect prompt injection, which is way more sneaky. This is where the AI picks up a hidden command from some external source it's looking at, like a web page it's trying to summarize or a document you asked it to read. The craziest part? The user might have absolutely no idea an attack is even happening. Okay, so now we can finally put all the pieces together. We started with those big, broad categories, and we drilled down into the nitty-gritty. So let's step back and take a look at the complete attack map. And here it is, the full map of the attack vectors we've been talking about. You can see at the top level, we've got our big three, misalignment, jailbreaking, and prompt injection. And then right below, you see prompt injection branching out into its two subtypes, direct and indirect. This simple chart, this is the exact framework security researchers are using right now to classify threats to AI models. So who cares? Why does having this map even matter? Well, because it takes all that vague fear about AI going rogue and turns it into a structured, understandable landscape of specific problems we can actually solve. Now, when you hear about some new AI security flaw in the news, you can place it on this map. You can understand how it works, and you can see how it relates to everything else. Having this framework gives us the clarity we need to see the road ahead. We've mapped the terrain, we've identified the ways in. So the critical question, the one everyone is working on, becomes, now that we understand how these systems can be broken, how in the world do we build the defenses to make them stronger?